Class, welcome back. Today we are going over our last new material before our chapter test. So these concepts are going to hopefully look very familiar. They're just kind of extending what we were already talking about in our previous video about maximizing area. Okay? So really, I don't have to go over too much on these learning targets. If we flip to the next page, the only thing I want to add a little bit. I want to say, not only can we write equations representing the area, but we're also going to start talking about a little bit of perimeter as well. Okay, still need to do domain. We still want to be able to graph area equations, but then again, we're also going to want to graph perimeter equations. So I'm going to add that. And then the other two are staying the same. Clearly label the axes, state dimensions. Okay, so let's jump into this. Let's see what's going on here. All right. When we look at this example, interesting. I don't just have quadrant 1 anymore. Okay, I have two quadrants. I have quadrant 1A and quadrant 2. So let's take a look. Let's read. Let's see what's going on. Rectangle is inscribed in a semicircle with radius 3, which has the equation y equals square root 9 minus x squared. Cool. Two vertices are on the semicircle. Okay. Two vertices are on the semicircle. Can I just pick any two places? No. What I want to do is I actually want to jump to this next part first, the third and fourth. Third is a positive x-axis. All right. So maybe I pick right here. That actually dictates my point along the semicircle, right? Because I have to go right above it. Why? I need 90-degree angles. I have to have perpendicular lines. So that kind of dictates what's going on the right side. And actually, that does the exact same thing, because what do we know? We know that rectangles have to have parallel sides, which means I have to be parallel to my line along the bottom, which means I then know my fourth point as well. Okay, so I went about it kind of a roundabout way. I went a little bit backwards. I knew that I could get a point along the positive x-axis, which then dictates my second point, which will be at x comma y, which then also dictates my point over here, because I know what? It has to have a y value of y. This is the tricky part. This is now going to be negative x, which means this is going to be negative x comma 0. Okay, so now I have my points. I can sketch. I can kind of see what I am trying to do. It says to express the area of the rectangle as a function of x. Well, we know rectangles are a equals b times h, base times height. So we start to put this together, and again, it's going to be a function in terms of x. So a of x, I need my base. All right, this is a little different than last time. A little bit different. I know from my origin to over here is x. I also know from my origin to the left to negative x is also x, which means, guys, what is my base here? X plus x. Ooh, it's no longer just x like it was yesterday. My base is 2x. What about the height? Well, height's kind of the same as yesterday's video. I know that this is just y. I know that I can't write y because my function is supposed to be a function of x. So what do? I know that for some given x value, my y value will always take the form square root of 9 minus x squared. Okay, so now I know that this represents the base, and this represents the height. And I'm going to draw my graph. Now again, think through this. I can't have negative values for the base. I can't have negative values for the area. So I only want quadrant 1. This is x. This is a of x. This is the area of rectangle. Now be very careful on this. Oh, sorry guys, a little bit off. Be very careful on this next part. X now, normally, or the last video, X was always the base of the rectangle. But in this case, my base is 2x, so when I say x, this is actually half the base. Okay? Okay. We don't know what to plot yet, because we did not find the domain. So let's draw that in. Even though we didn't necessarily put a section for it, we want to get the domain. And we still know that we use base has to be greater than 0, height has to be greater than 0. That's going to dictate what equations we write, or sorry, what inequalities we can write. Base is 2x. 2x has to be greater than 0. Height, square root of 9 minus x squared has to be greater than 0. I start solving. Okay, this is nice and easy. This is just x is greater than 0 still. This I have a little bit of work to do. If this is going to be greater than 0, what would I do? Maybe square both sides. Okay. I now have my inequality. It's a quadratic inequality, so I factor, which allows me to draw my number line. When I go, and I know it's going to be greater than, so I have to keep open circles, test a point, usually in the middle, 0. Ooh, that's good. 9 minus 0 is still greater than 0, so I know I would shade right there. So when I put these two concepts together, I get that the domain is, well, from my height, I know it has to be between -3 and 3. But if I add in this extra piece that from the base that x has to be greater than 0, well then I know that my final domain is 0 is less than 3. Or sorry, 0 is less than x is less than 3. So very similarly to last time, I could go 0, 1, 2, 3. And that is a good start. So now what we have to do is we have to go to the calculator, right? We don't know how to graph this area equation without using the calculator. So let's see what's going on. All right, I clear this out and I start to type 2x square root 9 minus x squared. All right, so that looks good. I go to my window, still 0 to 3, that's all good. I don't really know yet about the y max, so let's just graph it and see. Okay, I think that's going to work out. I think that's going to be okay. Last thing, just kind of notice, be very careful here. It looks like it stops, right? It looks like it doesn't fully hit. One thing I want you to kind of be able to do is I want you to be able to, the calculator, it's just little pixels, right? So it's kind of hard to understand what's going on right there. What I want you to do is I want you to basically trace to 3 to see what's going on there. And when we trace to 3, we see that it does actually hit y equals 0. So I know that I'm going to have points here and here. I knew that I could go up to close to 10. And it's going to look what? Something like that. Okay? Maybe not perfect, but something like that. Okay? So now what do we have to do? Well, we need to get the largest area, and we know the largest area is the largest y value in this case, or largest a of x value. So we go to our second calculate menu, we use the maximum feature. It says to go left bound. One thing I also want you guys to be able to do is understand that you don't always have to click over. Like, I know that 1 is about here, so I'm just going to hit 1 enter, and look, it got me my left bound for me. So now right bound, well, right bound, I'm just going to go all the way to the end. I know it's going to be before 3. Okay, so that set my right bound, and then just move a little bit over to guess. And now we know that we have at 2.12 comma 9 is that maximum point on our graph. All right? So we move over. It says for what value of x is the area of the largest? Well, that's just the x value from before. So 2.12 units would be our answer to the first part. It says to get this, or the dimensions, okay? So dimensions are always base times height, at least for rectangles that is, I should say. So our base, be very careful. On the page, or on the last video, we were always able to just use whatever we got. But in this case, please note, my base is no longer just x, it is 2x. So I need to do 2 times that. So this is where I'll go to my calculator, I'll quit out, and I'll do 2x. And why can I do this x again? Because the x is still stored from when I calculated the maximum. So that gets me 4.24 units. And then the height is just that original square root of 9 minus x squared. So I'm going to punch that in, 9 minus x squared. Enter, 2.12. 2.12 units. Okay? Cool. So that hopefully should be kind of a little bit of a review from yesterday, or from the last video I should say. Only difference is you had to make the connection that because I'm going into quadrant 2, my base was not just x, it was 2x. Now, part D, and moving forward, this is introducing the concept of perimeter. It's honestly, guys, it's the same exact thing, it's just what? Our area formula is not the same as our perimeter formula. Perimeter, for rectangles at least, is what? The perimeter is 2 times the base plus 2 times the height. And why is that? If we look at our picture, remember, perimeter is all the way around. All the way around. So if let's say I start here. Well, I'm going 2x, and then I'm going y, and then another 2x, and then y. Or really, I'm going a base, a height, another base, another height. So 2 bases and 2 heights. So when we take this idea and now we incorporate x's, it would look something like this. Two times the base of 2x plus 2 times the height. But again, we need to make it a function of x. So this y is not okay. So we clean this up. First things first is we could definitely kind of combine these two concepts. 2 times 2x is just 4x. And then we have 2 times that original function, square root of 9 minus x squared. Okay, so this is now what we are going to graph. Again, nothing changes in terms of the fact that you can't have negative perimeter, you can't have negative base values. Alright, so we're still just plotting the first quadrant. Now we're going P of x though, which is the perimeter of the rectangle, and our x, which is still half the base. Let me move my hand so you guys can see what I'm doing there. Oh, and I'm off the map, or off the page. There we go. Sorry about that, guys. Okay, so again, P of x is the perimeter, x is half the base. Question, do I need to redo all of my domains? No, you do not, because think about this. What did we start by doing? Domain from this problem was that base has to be greater than 0, height has to be greater than 0. That concept stays the exact same for perimeter. So we know that our domain is not changing. I know that I'm still going 0, 1, 2, 3. Okay? We're ready to graph. Let's see here. Alright, so now we use our new perimeter function. 4x plus 2 square root 9 minus x squared. That looks good. Window. I'm not really sure what's going on with the y max yet, so let's just graph it and see. What does this look like? Ooh, so we're definitely not good. Yeah, let's raise this up a little bit. Let's go to like 20. Interesting. Interesting. Okay, so 20 definitely works. So we can definitely put 20 on our perimeter, our y scale, or perimeter scale. This is goofy though. I don't know exactly what's going on here. Is this dropping all the way down to 0 like it has in the past? Again, I would trace, I would figure it out. I trace, I hit 3. Ooh, it's only going to 12. So let's put some extra points. I know this is going to be about 12. Where's it starting? Trace. What value am I going to trace to? I'm going to plug in 0 for x. And it tells me that it's starting at 6. So something like that. And then we just kind of sketch it. Something like that. Alright, not perfect, but good enough. At least for our picture. Okay. Conceptually, nothing changes now, guys, okay? What is it saying? It says for what value of x is the perimeter the largest? Well, what did we do before? If we had an area function, or area graph, we found the maximum. We do the same thing. Bring back our calculator. Oop, wrong button. Calculate the maximum. Left bound, I'm going to say x is 1. Right bound, I'm going to say x is 3. And then I'm just going to kind of do a quick guess. Cool. I now have something like this. Not quite drawn to scale, but again, good enough. 2.68 and then 13.42. All right. Again, don't touch anything as you move your calculator off to the side. We can answer some questions now. For what value of x is the perimeter the largest? We know that it's 2.68 units. What is the largest perimeter? 13.42 units. Not squared, right? Perimeter is just all the way around. It's not square units. It's just units. This one didn't ask for dimensions. If it did, I think you would be more than capable of finding them by going back and figuring out, well, that what? This was our base. This was our height. So you would be able to plug in to get those values if you needed them or if you were ever asked. Okay? Okay, so the last part, I want you to stay open-minded on this. This is very generic, all right? This next page of notes is very generic, and by that I mean this parabola, this circle down here in the last one, they're not exact equations, okay? So we can't get the actual y value, all right? We can't get the actual y value. And what I mean by that is when I go to write an area equation, well, this is a square, or really, I would want to say it's a rectangle for right now, because I'm not exactly sure if it's a square, which means I'm going to be using a is equal to bh. Well, that means I need to get the base and the height in terms of my coordinates. Well, a base would just be my x value, and my height would just be a y value. Did I say that right? Base is x, height is y. So in this case, I would have a of x is equal to x times y. But again, remember, I would have to change this. And again, I can't change that right now because I don't know my equation, my specific equation for y. All right? What's going on in number 2? Well, this is now a triangle, so area equals 1/2 base times height. Same concept though. My base is x, my height is y. So here I would have a of x equals 1/2 times the base, x, times the height, y. I'm going to make my same note. Oh, shoot. That's going over here to y. I'm sorry, guys. Okay. All right, when we check these other two, well, these I would say are similar to what we did in this video, in the first page. Okay, this is a little different. Normally, like on this one, when I'm just in quadrant 1, my base is just x. When I look at something like number 3, well, I can see that from here to here might be x, but from here to here is also x, so my total base is 2x. And here, my height is still y, so again, it's a rectangle, a equals bh. What would I say? Area equals my base, which is 2x times the height, which is y. And when I clean this up, I would probably say something like 2xy. I'll bring my same note down to this y value. And when we take a look at this last one, probably the most confusing one, but really, hopefully, if you're understanding the concepts of moving around the coordinate plane, I think you should be able to understand this one. Well, here, right, from here to here is x, and then over here from the origin back the other way in the negative x direction would be another x. So my base, once again, just like in number 3, my base is 2x. What's going on with the y's? What's going on with the y's is I would go up from here to here. On the positive side of the x-axis would be 1y. And in the negative direction, or on the negative side of the x-axis, would be another y. So if I combine them, I get a height of 2y. So now when we put this all together, again it's a rectangle, its area is equal to base times height. Well, that means area will be base 2x times height 2y. And when I combine these ideas together, I would get 4xy. And lastly, just to kind of stay with the pattern, I have to bring my note along to that y value. Okay, again, this page was for you to understand conceptually what's going on in these pictures. I know that we would never, ever, ever have a y in any of these equations, but in this case, we don't have the equation to plug in for y. All right, so now that we have gone through all of this, I am hopeful that you are feeling more confident on writing equations that represent area and perimeter. I hope you feel confident stating the domain of those area and perimeter equations. I hope that you can graph those equations and are able to use your calculator to find those max points. And then again on your graph that you can label clearly the axes and indicate what everything represents. And of course, lastly, that you can understand what are the different dimensions based on your graph. All right, I hope you have a great day. Again, we will work on this in class. Peace.